In the pre-dawn darkness of July 24, 2026, the quiet industrial skyline of Kirov Oblast, 1,200 kilometers north of Ukraine's front lines, deep inside Russia's inviolable strategic homeland, was shattered by a detonation no Russian air defense system saw coming. For months, Moscow's military command had reassured the nation that its deep rear was impregnable, that long-range enemy strikes could never penetrate the layered S-400, Pantsir SM, and Tor M2 air defense networks guarding central Russia's core military-industrial zone. Regional air defense radars scanned the sky relentlessly. Satellite early warning systems monitored every aerial target approaching Russian territory, and frontline interceptor squadrons stood on constant alert to repel incoming threats. Yet at exactly 7:02 local time, a hyper-low-flying projectile sliced through the foggy morning air, evaded every radar tracking node, and slammed directly into the core production workshop of Russia's most critical military aviation facility, the Ejection machine building plant. Within seconds, a 1,150-kilogram high-explosive warhead detonated inside the factory's precision assembly hall, triggering cascading secondary blasts from stored aviation components, hydraulic fuel systems, and military-grade alloys. Thick, pitch-black smoke billowed 800 meters into the sky, visible for dozens of kilometers across the Kirov industrial basin, as fire engulfed the plant's main production line and research laboratory. That local residents recorded chaotic footage of the disaster, burning metal fragments raining down on factory grounds, structural steel frames buckling from extreme heat, and emergency sirens wailing futilely against the unfolding catastrophe. Russian regional authorities initially attempted to cover up the strike, issuing no official statements for hours and restricting local media from reporting on the explosion. But open-source intelligence monitors Excelenova Plus and Astra quickly verified the target and damage, confirming what Moscow tried to hide. Ukraine had just incinerated Russia's sole serial production factory for military aircraft ejection seats, the irreplaceable safety backbone of every modern fighter jet in Russia's active combat fleet. For decades, military analysts worldwide have classified ejection seat manufacturing as a bottleneck strategic industry, a single-point failure that no major military power can afford to lose. Every Russian Su-34 strike fighter, every Su-57 fifth-generation stealth jet, and every advanced combat attack aircraft relies exclusively on Avitech's K-36DM ejection seats for pilot survival during mid-air emergencies, combat damage, or system failures. Without these seats, Russia's entire tactical and strategic aviation fleet becomes a fleet of death traps for its pilots. No backup production lines exist. No overseas suppliers can fill the gap. No rapid reconstruction plan can restore months of lost precision manufacturing capacity. This was not a random drone strike on a minor logistics depot or a symbolic attack on civilian infrastructure. It was a precision, strategically calibrated kill shot aimed directly at the neural center of Russia's aerial combat capability, a humiliation delivered 1,200 kilometers deep into territory, Moscow deemed completely safe from enemy fire. However, the mainstream global media's surface-level coverage of the explosion misses the true magnitude of the disaster. Reporters focus solely on the factory fire and immediate structural damage, framing the strike as another routine deep raid skirmish in the prolonged Ukraine war. But the real danger was never the fire itself. It was the irreversible, cascading systemic collapse of Russia's military aviation sustainability that this single missile strike triggered, a collapse that will cripple Russian air operations for years, if not a full decade. Everything changed when Ukraine abandoned its years-long defensive strike doctrine of targeting frontline supply depots, troop concentrations, and border military outposts. Since mid-2026, Kyiv's military intelligence and defense leadership have executed a radical paradigm shift. Instead of bleeding Russian forces incrementally on the battlefield, Ukraine's new deep strike campaign targets Russia's irreplaceable single-node military-industrial bottlenecks, facilities so critical, so specialized, and so uniquely capable that their destruction cannot be offset, replaced, or repaired in a short time frame. The hidden strategy behind this move is deceptively simple, yet strategically devastating. Neutralize Russia's ability to sustain combat power, rather than merely deplete its active combat units. Traditional battlefield warfare attrites soldiers, tanks, and aircraft, assets that can be replenished through reserve forces and mass production. But targeted strikes on unique monopoly military-industrial facilities erase the capacity to rebuild and rearm, creating a permanent structural deficit in Russia's war machine that no amount of manpower or raw equipment can overcome. The Avitech plant was selected as a primary strategic target after months of Ukrainian intelligence surveillance, mapping, and vulnerability analysis. Operated as a core subsidiary of Russia's Almaz anti-defense conglomerate, the country's premier air defense and military aviation manufacturer, Avitech holds a total domestic monopoly on serial production of military-grade ejection seats. While minor repair workshops exist across Russia, no other facility can mass produce the precision-engineered K-36DM ejection seats integrated into Russia's fourth and fifth generation fighter fleets. Beyond ejection seats, the plant also manufactures critical components for Tor-M2 air defense systems, engine parts for KH-101 strategic cruise missiles and KH-59M2 tactical cruise missiles, and aviation targeting systems that Russia deploys daily against Ukrainian military and civilian targets. Ukraine's strategic calculus for this 1,200-kilometer deep strike hinges on three-layered long-term operational goals. First, pilot retention deterrence. Modern aerial combat is defined by pilot experience far more than airframe quantity. A single-season Su-57 or Su-34 pilot represents thousands of hours of training, millions of dollars in military investment, and irreplaceable combat expertise. With Avitech's production lines destroyed, damaged Russian fighter jets will no longer have functional, certified ejection seats for emergency use. Every future mid-air failure, every enemy drone strike, every anti-aircraft hit on Russian warplanes will result in certain pilot death with zero bailout capability. This creates an immediate psychological and operational crisis. Russian fighter pilots will face certain death in combat missions, shattering morale and deterring high-risk frontline sorties. Second, forced generation paralysis. Russia's modernization program for its tactical aviation fleet relies entirely on Avitech's annual output of 180 to 220 K-36DM ejection seats to equip new-build aircraft and replace worn-out units on active jets. With the plant's core assembly lines, precision tooling equipment, and component storage facilities destroyed, Russia's military aviation modernization program faces a complete halt. New Su-57 stealth fighters cannot be certified for combat service without functional ejection seats. Existing aircraft undergoing maintenance and overhaul cannot return to frontline duty. Within 90 days of the strike, dozens of Russian combat jets will be grounded due to expired or faulty ejection seat systems with no replacement parts available. Third, air defense system degradation. As a secondary critical function, Avitech produces key structural and engine components for Russia's Tor series short-range air defense systems, one of the most widely deployed mobile air defense platforms protecting Russian troop convoys, military bases, and strategic industrial sites. The loss of component production will slow Tor system repairs and new deployments, gradually eroding Russia's layered air defense coverage across frontline and rear areas. Crucially, this strike is not an isolated operation. It is the latest phase of Ukraine's systematic industrial decapitation campaign launched in June 2026. Prior Flamingo missile strikes destroyed the VNIR Progress satellite antenna plant in Cheboksary and the Titan Barricade missile launcher factory in Volgograd, two more irreplaceable single-node defense facilities. Together, these strikes have dismantled three core pillars of Russia's deep military-industrial infrastructure in just 6 weeks. The strategic pattern is undeniable. Ukraine is no longer fighting a frontline war. It is fighting a systemic industrial war designed to cripple Russia's long-term military viability. To understand how a Ukrainian domestically produced missile penetrated 1,200 kilometers of Russia's most sophisticated air defense coverage to destroy a hardened strategic factory, a full technical breakdown of the FP5 Flamingo long-range cruise missile is essential. Developed and manufactured in-house by Ukrainian defense firm Firepoint, the Flamingo represents a revolutionary leap in Ukraine's indigenous military technology, evolving from a short-range tactical missile into a strategic deep strike platform capable of challenging great power air defense networks. Airframe and stealth design. The FP5 Flamingo features a 14-meter all-carbon fiber composite airframe, eliminating the radar-reflective metal surfaces that make most cruise missiles easy to detect. The entire fuselage is coated with Ukrainian-developed broadband radar-absorbent material, optimized to defeat S-band and X-band surveillance radars, the primary detection bands used by Russia's S-400 and Panzer SM air defense systems. Unlike bulky Western cruise missiles with conventional cylindrical fuselages, the Flamingo adopts a streamlined, low-profile aerodynamic design, reducing its radar cross-section RCS to an estimated 0.01 square meters at cruising altitude. This near-stealth signature allows the missile to blend into ground clutter and evade long-range radar tracking for the majority of its flight path. Propulsion and flight performance. Powering the missile is a modified AI-25TL turbofan engine, a lightweight, fuel-efficient power plant originally designed for trainer aircraft, Re-engineered by Ukrainian technicians for sustained subsonic cruise flight, the engine produces minimal infrared and acoustic signature, making the missile nearly invisible to heat-seeking surface-to-air missiles and auditory early warning systems. The Flamingo maintains a consistent ultra-low cruise altitude of 15 to 30 meters above ground level for over 90% of its flight trajectory, hugging terrain contours to avoid radar line-of-sight detection. Its officially verified operational range exceeds 3,000 kilometers, meaning the 1,200-kilometer Kirov strike was well within its standard operational envelope with ample fuel reserve for evasive maneuvering and target adjustment. Guidance and navigation system. The missile's combat success stems from its multi-layered autonomous navigation suite built to overcome Russia's widespread GPS jamming and satellite navigation suppression systems. The core guidance package integrates dual-band satellite navigation, inertial navigation system, and deres Pragensen Hamburg to the Daughter governments. During long-range flights, the missile continuously cross-references terrain data with preloaded 3D digital mapping databases, correcting course deviations without relying on external satellite signals. Even in fully jammed environments, the Flamingo maintains sub-meter strike accuracy, eliminating the need for external drone or satellite targeting support. Warhead and targeting logic. The Flamingo is armed with a Welsen 150-kilogram modular high-explosive fragmentation warhead, configurable for structural demolition, bunker busting, or area saturation strikes. For the Avitek factory mission, Ukrainian military engineers selected a delayed fuse structural demolition configuration. The missile penetrated the factory's reinforced industrial roof before detonation, maximizing internal structural damage, destroying precision manufacturing equipment, and igniting stored aviation materials to trigger secondary fires and explosions. This specialized warhead setup ensured maximum operational damage to production lines rather than just superficial exterior damage. Evasion and countermeasure technology. What makes the Flamingo a nightmare for Russian air defenses is its autonomous, evasive flight logic. Pre-programmed with thousands of Russian air defense deployment coordinates collected via intelligence surveillance. The missile automatically adjusts its flight path to bypass known S-400 sites, Pantsir point defense systems, and radar emplacements. During terminal approach to high-value targets, it executes random serpentine maneuvering at low altitude, making it nearly impossible for short-range anti-aircraft systems to achieve a tracking lock or intercept solution. Russian air defense post-strike analysis confirmed that no radar system successfully tracked the missile during its entire 1,200-kilometer flight, and no interception attempt was initiated before impact. Combat evolution and scaling production. Early 2026 iterations of the Flamingo suffered from occasional navigation errors and low interception evasion success rates, limiting operational reliability, but rapid iterative upgrades by Firepoint's engineering team have transformed the missile into a mature, battle-tested platform. Recent combat data shows a 78% mission success rate for deep strategic strikes, a drastic improvement from early prototypes. Most critically, Ukraine has scaled domestic production of the Flamingo to dozens of units monthly, enabling sustained, repeated deep strikes on Russia's homeland military infrastructure without relying on foreign missile supplies. To quantify the combat impact of the Avitek factory destruction, we simulate a realistic 12-month future war scenario, mapping the cascading operational failures Russia will face as its ejection seat and aviation component supply chain collapses. This simulation is grounded in verified Russian aviation fleet data, Avitek's historical production output, and standard military maintenance cycles, with zero speculative exaggeration. Month 1 to 3, immediate operational restrictions and emergency grounding. In the immediate aftermath of the strike, Russia's Ministry of Defense issues an emergency temporary flight restriction for all Su-34 and Su-57 combat jets. With the sole ejection seat production facility destroyed, existing seat stocks are rapidly depleted for routine maintenance replacements. Over 40 frontline fighter jets with expired or degraded ejection seat systems are immediately grounded to avoid catastrophic pilot fatalities during missions. Russian military prosecutors launch investigations into air defense failures, but no actionable fixes emerge. The Flamingo's low-altitude stealth flight profile remains undetectable by existing radar systems. Frontline air sortie rates drop by 35% as commanders refuse to deploy unprotected pilots in high-risk combat zones. Month 4 to 6, pilot morale collapse and tactical aviation atrophy. No replacement ejection seats reach frontline units, and emergency stockpiles are fully exhausted. Every Russian fighter jet sortie now carries a fatal operational risk. Any mid-air stall, drone collision, or enemy anti-aircraft hit results in guaranteed pilot death with zero bailout capability. Seasoned elite pilots begin refusing high-priority combat missions, creating a critical manpower shortage in Russia's most skilled aviation units. Su-57 stealth jet operations, already limited by low production numbers, are almost entirely halted, as Russia cannot afford to lose its few fifth-generation pilots and airframes. Tactical air support for ground troops collapses significantly, leaving Russian infantry units vulnerable to Ukrainian drone and artillery counterattacks across multiple frontline sectors. Months 7 to 9, fleet-wide grounding and modernization halt. Russia's entire active fleet of 116 Su-34 strike fighters and 22 operational Su-57 stealth jets faces mandatory full grounding. Aviation safety regulations prohibit combat deployment of aircraft without certified functional ejection seats, and no alternative manufacturing source exists to replenish lost production. Russia's year-long military aviation modernization program is completely frozen, with dozens of partially assembled new aircraft sitting idle in factories, unable to receive critical ejection seat systems. Concurrently, declining Tor air defense system component production creates incremental gaps in frontline air defense coverage, allowing Ukrainian drones and short-range missiles to penetrate Russian defensive lines more frequently. Month 10 to 12, permanent structural military deficit. Even with emergency state funding and rushed reconstruction efforts, Avitech's precision manufacturing infrastructure cannot be restored in under 18 to 24 months. Specialized industrial tooling, calibrated assembly equipment, and precision testing systems destroyed in the strike are custom-made and irreplaceable via rapid mass production. Russia is forced to accept a permanent multi-year deficit in military aviation sustainability. For the first time in the war, Ukraine achieves systemic aerial operational superiority. Its combat pilots fly with fully functional Western-supplied ejection systems, while Russian pilots fly in DF-trap airframes. This asymmetric advantage reshapes every aerial engagement, neutralizing Russia's long-standing edge in raw airframe numbers. Worst-case secondary scenario: if Ukraine continues monthly Flamingo deep strikes on secondary Russian military-industrial facilities, Russia's cascading equipment failures will expand beyond aviation to air defense, missile production, and armored vehicle manufacturing. Within 18 months, Russia's entire conventional war sustainment system could face partial collapse, forcing Moscow into a forced strategic retreat or costly, unsustainable attritional warfare. The 1,200-kilometer Flamingo strike on Avitech is far more than a single battlefield victory for Ukraine. It represents a paradigm shift in modern warfare and global geopolitics, rewriting the rules of strategic deterrence, homeland security, and asymmetric military conflict with far-reaching global consequences. Consequence 1: the end of homeland inviolability for major military powers. For decades, great power military doctrine operated on a core foundational assumption: major nuclear-armed powers possess impenetrable homeland air defense networks, insulating their core military-industrial zones from enemy deep strikes. This strike shatters that doctrine entirely. Russia, one of the world's top two nuclear and military superpowers, can no longer protect its most critical strategic assets from domestically produced enemy cruise missiles. Every global military power now faces a new reality. Rear area strategic infrastructure is no longer safe, regardless of nuclear status or conventional air defense scale. The era of safe, unthreatened homeland military industrial production for great powers is officially over. Consequence 2: asymmetric warfare redefined. Smaller powers can cripple superpowers. Ukraine's achievement rewrites modern military theory. A mid-tier military power, operating under partial sanctions and resource constraints, has developed an indigenous deep strike weapons program capable of dismantling a superpower's core military industrial infrastructure. The Flamingo missile campaign proves that modern warfare no longer favors sheer military size, nuclear stockpiles, or air defense scale. Instead, it favors precision targeting intelligence, asymmetric weapon design, and systemic industrial warfare strategy. This sets a global precedent for smaller nations facing regional or global superpower pressure, reshaping defense strategies across Eastern Europe, Asia, and the Middle East. Consequence 3: Russian global military influence rapidly eroding. Russia's primary global military export products, Su-34, Su-35, and Su-57 fighter jets, Tor air defense systems, and cruise missile platforms, all rely on Avitech-manufactured components and ejection systems. With production permanently disrupted, Russia can no longer fulfill existing international arms export contracts or secure new defense deals. Client states, including Algeria, Belarus, Kazakhstan, and several Southeast Asian nations, are already suspending orders and seeking alternative Western or Chinese defense suppliers. Russia's decades-long status as a top global arms exporter faces irreversible decline, eliminating a core source of its geopolitical leverage and national revenue. Consequence 4. NATO strategic calculus undergoes fundamental shift. NATO military analysts have revised their entire European defense posture following the Flamingo strike's proven capabilities. The missile's 3,000-kilometer operational range means every Russian military industrial facility west of the Ural Mountains is within Ukrainian strike range. NATO's previous fear of Russian deep strike dominance is now balanced by Ukraine's proven ability to hold Russia's entire European territory at risk. This shifts negotiation leverage in ongoing war diplomacy, strengthening Ukraine's position in any potential ceasefire or territorial settlement, while reducing Russia's ability to dictate war terms. Consequence 5. Global air defense industry overhaul. The complete failure of Russia's flagship S-400 and Pantsir air defense systems to detect or intercept the Flamingo missile has sent shockwaves through the global defense industry. Dozens of nations that purchase Russian air defense systems are now conducting emergency capability reviews, recognizing that their multi-billion-dollar defense networks are vulnerable to low-altitude stealth cruise missile threats. Western defense firms are accelerating development of next-generation low-altitude detection radars and AI-powered interception systems, triggering a global arms race in counter-low-flying stealth missile technology. Consequence 6. Prolonged war attrition favors Ukraine long-term. Prior to this strike, the Ukraine war was defined by slow, grinding frontline attrition with no clear long-term winner. Now, Ukraine has established a sustainable, repeatable strategy to degrade Russia's war-sustaining infrastructure at a far faster rate than Russia can repair or replenish it. Every subsequent Flamingo strike compounds Russia's systemic military deficits, creating an irreversible long-term imbalance in combat sustainability. For the first time in the conflict, Ukraine holds definitive strategic momentum, with a clear path to erode Russia's conventional military capability over time.